Alright, this is an example of doing a line integral. And to do that, we need to reconstruct our integral that we have in this form here that's way easier to evaluate. So we are given our curve already parametrized. So to start our integral, we're integrating from a to b, and this is going to be from 0 to 1. 0 to 1. And then for our function here, we're going to need to take the derivatives here and rewrite this. So we want the derivatives of all these functions, x prime of t, fortunately they're very easy in this case, 1, y prime of t just equal to 2, z prime of t just equal to 1 again. And then using these definitions right here, we can rewrite our function in terms of t. So if x is just equal to t, then x squared is t squared, minus y is equal to 2t, so minus 2t, plus 3z, and z is just equal to t again, so plus 3t. Now ds we replace with this r prime dt, and this thing is the magnitude of all of these derivatives. So we use the distance formula, and we have x prime of t squared, or 1 squared, plus y prime of t squared, or plus 2 squared, and z prime of t squared, 1 again. And this is equal to the square root of 6. And so the square root of 6 dt finishes out our integral. 6 dt. And this we can almost integrate. Let's make it just a little bit simpler. 0 to 1, t squared, and then combine these two terms to just get plus t. The square root of 6 is a constant, so it can slide through all the way to the beginning, and we still have dt. And this is simple to evaluate, so we have the square root of 6. We'll put our bar here. 1/3 t to the third plus 1/2 t squared. We're evaluating that at 1 and 0. So we have the square root of 6 times 1/3, and then put the 1 in, 1 cubed, plus 1/2 1 squared, and then minus these two things at 0, 0 out. We have this. This makes 5/6, so we have 5 on top, 6 on the bottom, and the square root of 6 still here. So the value of this line integral right here and this function is 5 square roots of 6 over 6. Thank you, and please tell me what you'd like to see next in the comments.